Hello, everyone. Are you getting me?
Yes, we are getting you. Yes.
Okay. Yes. You can try this for you. It's not the best. Yeah, I think we can start. Maybe let me show my face briefly, and then I can. I don't think it adds a lot of value. But it's good to know who is talking to you. Then from time to time, I can come back. For those who would want to see me. So let me share my screen. We are going to start with just a brief look at exploratory data analysis. This is going to be a little bit of theory. No volume? Okay.
Your volume is clear. I think.
Oh, okay. I think it's for Susan, which is not clear, but that's okay. I'm going to. Yeah. So what I want us to look at briefly before we start looking at the practical aspect of it. Yesterday, the last 2 days, we got ourselves into ARA and ARA Studio. We were able to let's install ARA and ARA Studio. We are able to put in some commands that we're able to install and call the libraries. We are going to continue from where Ellen left. But before we do that, I want us to just go through what I consider one of the most important things in data analysis, that is exploratory aspect of it. We can always look at a data set as if you look at this information, for example, let's say we are interested in height of human beings. Of course, you want to know the shortest person, you want to know the tallest person, you want to know the average height. You may also want to know the different, like the first quartile, the second quartile, the median, or the third quartile. These are the kind of thing that you want to know. So what is exploratory data analysis? So the first thing is that this is an approach that is aimed at summarizing the main characteristics of the data using numbers and graphs. We already saw some summaries like Ellen gave us yesterday. So it's always supposed to be the first step in your analysis. It will be unfortunate if you go straight away and you want to do analysis of variance, you want to do regression analysis before actually trying to do some exploratory data analysis. So the main goal of exploratory data analysis is simply to obtain confidence in your data to a point where you're ready to engage in some inferential statistics. So you're ready to do some modeling. So these are, I would say, these are the main reasons why we do exploratory data analysis. The first thing is you want to maximize insight into the data set that you have. After collecting your data, either from the field experiment or from survey, you want to actually know what is there in your data set. You want to know, are there relationship between variables? Let's say, do women run faster than men, or maybe people from a certain area shorter than people from another area. You also want to determine to see whether there are some kind of maybe there are mistakes, or there are some values that seems not to really to relate or to be together with others. If you're looking at, for example, you go to a primary school and you want to say, you want to measure maybe the intelligence or IQ of the kids, and you find one kid with the, say, IQ of 600 and the rest are in 200, 150. So that particular value will be of interest. So you want to know, is this actual real value, or could it be that this is an error? So there are also assumptions that are related to data analysis. So for example, if you do analysis of variance, you know that the data should be normally distributed and so on. So this is one, at this stage, you'll be able to see whether some assumptions are actually violated or not. You can suggest also the hypothesis that can be tested, and then you also be able to come up with the tools that you will use for your data analysis. So in short, or in summary, you want to pick the big picture, look at the data. You want to check whether there are some obvious mistakes. You want to learn about the distributions of the different variables, and you want to know if relationship exists between the different variables that you have. So we certainly need to pay a lot of attention to exploratory data analysis, and please don't do your analysis don't go to rush to try to do analysis of variance or statistical modeling before you explore your data. There are a number of methods that we can use for data analysis, exploratory. Let me just have a table. Okay. So for example, you can use, you can have summary based on just numbers versus graphs. So you can use the mean, the median, or you can go and use things like the histogram, the bar graph, and so on and so forth. You could also look at the method of exploratory data analysis, whether you are dealing with one variable at a time, which is univariate, versus the multivariate, where you're going to deal with more than one variables at a time. You could deal with two variables at a time, three variables, or four variables at a time. That would be what you want to do. So based on the two categorizations, we can have, for example, numerical univariate. So let's say, for example, yesterday Ellen showed us one data set, and then in that data set there are several variables. So if you look at one of these variables at a time, and if you want to use mean, the variance, this is what called univariate. Numerical, you can also use univariate graphical. Then you can have numerical multivariate, and then you have graphical multivariate. So we are going to look at each of these methods in relation to a data set that we are going to describe shortly. So this is a graphical, this is a table that shows the different methods that are available. This is not an exhaustive list. The presentation was already given to you yesterday. So at least if you're keen enough, you should have probably really looked at it. Okay, so under univariate, you can look at the measure of center or location. So things like the mean, the median, the mode, the quartiles. You can also look at the measure of spread. So under spread, we have things like the range, we have variance, we have standard deviation, and then we have things like the interquartile range. You can also look at frequencies and percentages. I think we saw yesterday how to generate some frequencies using the summary tools. I think this one was one of the things Ellen did yesterday. And then graphically, we're going to look at things like box plot, histogram, the stem and leaf, bar graph, bar chart, and line graph. So these are if you're looking at one variable at a time. So let's say you want to see, for example, the age of the children, the height of the children, maybe the weight. So you can look at each variable at a time, either using numbers or using graphs. But you can also look at more than one variable at a time. You may be interested in looking at height versus weight. You may be interested in looking at sex versus distance from education. So under this, the multivariate, we have different tools. We have things like cross tabulation, we have covariance and variance matrices. Graphically, you can use the scatter plot, you can use bar graph, histogram, and box plot. We are also going to have a bit of time to actually look at this graphical method for numerical for multivariate data analysis. We have a small data set. If you've attended our training before, probably you're already aware of the data set. So we are going to look at a data set. So this is a data set about employees of a certain company. This data set is got from SPSS. So there are a number of variables that we are interested in studying. So the first thing is we want to know maybe the sex of the employee or gender, whether male or female or man or woman. We want to know the number of years somebody spent at school. We want to know the job description. We want to know the current salary, the beginning salary, time spent on the job, previous 6 years experience, and whether somebody is minority or not. So here, the main area idea or the main possible area of study would be whether there is the discrimination based on gender or based on minority classification. So in some cases, they are complaining that maybe the female are favored for a particular job than the men, or the other way around. So this is how the data set look like. What Ellen talked about yesterday, we talked about a data frame. So a data frame is simply you have rows and columns. Let me try to get a pen. So these are the rows. These are our columns. So for example, if we look at the first person here is male, date of birth, 3rd February, 1952, spent 15 years at school. This person is a manager. This person earns currently earns $57,000, and then started work when he was earning 27,000. So you can see that the salary has almost as doubled, more than doubled. The time spent on jobs is in months is 98. Previous years experience, and then the minority is not a minority. And this you can either be a minority or a non-minority. So when you're collecting your data, in most cases, your study unit, you need to have one study unit, and each study unit, all the information relating to the study unit can actually enter into one row. This is for ease of analysis, but especially if you're not, you don't have a lot of knowledge on the computer. But if you're very good at programming, you can always play around. But this is kind of a data set that Ellen was talking about, data frame that Ellen was talking about. Is similar to what we know in Excel and other packages. So what we are going to do is we are going to start by summarizing the quantitative variables. I don't know from the chat, what is a quantitative variable? Can you try to give us a definition what a quantitative variable is? I want to see some answers in the chat. Say measurable, somebody say age, numerical variable, age, dealing with numbers, salary, numbers, okay, numerical, okay, express, okay, good. Okay, that's fine, we can stop there now. Some people are giving examples, some people are defining it, which is okay. At least I see that we have some knowledge. We can stop there now, okay? So quantitative variables are variables that can be measured, that can be quantified, either by some measurement scale or by counting. Okay, so here height, for example, is a quantitative variable, and it is continuous in that you can measure over some continuous scale. So one of the easiest way to summarize a quantitative variable is by what we call a 5-number summary. and the 5-number summary can be expressed as the box plot. So the 5-number summary is simply the minimum value. So you want to know what is the minimum value. You want to know what is the maximum value. You want to know the value that divides the population into half. That is the median. So 50% of the population will be below this value, and 50% of the population will be above that value. And then the first quartile, divides the data into quarters. 25% of the data will be below the first quartile, and 75% of the data will be above the first quartile. Then the third quartile is the opposite. 75% of the population will be below, and 25% will be above. So if you want to know the top 25%, that is, you go for the third quartile. Now, this same information can be presented. The same information can be presented in a box plot. So a box plot, you'll have the lower whisker and then the upper whisker. We're going to look at this shortly. So let's first identify which variables from here are quantitative. Can you identify the variable that are quantitative? Let's try and see in the chart. One variable that are quantitative that you think is quantitative from here. Years at school, yes. Salary, current salary, okay. Okay, great. Time on job, good. ID is not quantitative. Okay, we can stop there. Okay, so these are the variables that are the one in green are the ones that are quantitative. Number of level of education, that is the number of years at school. Current salary, beginning salary, time on job, and previous experience. Now, it's very, very important to differentiate between quantitative and qualitative data, between continuous and category and this quantitative and categorical, between continuous and discrete. So all this information are available. I'll ask you to go and read them online. So these are the one in green. This is one of them. So these are the ones that we have as our quantitative variables. So here, the gender is categorical, job category is categorical, and then minority classification is also categorical. So the first thing that we need to do is to do the 5-number summary. So the 5-number summary is simply going to tell us from here, from this data, we can see that in this company, the least educated person is 8 years old. And then the most educated is 21 years old. And then at least 75% of spend less than 15 years at school based on the upper quartile. Now, assuming now that the minimum value here was -10, what comment can you give about this? If the value was -10, I want to see in the chart. Is it possible to have -10 years at school? This is impossible. So what could be, somebody says an outlier, what could be the reason? What could be here? What could be the thing? Could be an error. So you need to go and check and say there's somebody who has spent -10 years at school. I don't know whether that person, after going to school, then they took them to a witch doctor and they tried to extract as much information from the head as possible so that the person go backward 10 years. Okay, great. So we can't, this information is enough to actually start a discussion with your supervisor or with your student. You're saying in this case that the least educated person in this company spent 8 years at school, the most educated spent 21 years at school, and then at least the 75% of the population spent 15 years at school. Which value, what percentage spent 12 years at school? What percentage of what proportion of the population spent 5 years at school? Okay, I see 12 years at school, half. Okay, here you can see here that we have both the median is the one that tells us that at least 50% of the respondents spend 12 years at school. But you can see from here that the median and the median and the lower quartiles are the same. So here you can see this thickness here. So this is what we have. Okay. So here we can see that this is the upper quartile, which is at 15. You can see from here. Then the median and the lower quartile are at 12. The minimum value is at 8. Okay, then the maximum values here, that this maximum value here, this is the one that is, this is our 21. But there's also another value here, which is I think is 19. So now these two values, that is 19 and 25, have been marked as outliers. From here, you can see from here that they're outliers. And how do we calculate the outliers? The outliers are simply what by this. So here, from you get the upper quartile, you add 1.5 times the interquartile range, going in this direction. Once you specify that point, anything below, anything above that will be considered an outlier. You come and do the same here. Anything below here will be considered an outlier. So in this case, there are no outliers below, but there are outliers up. So these people here seems to have studied more than the rest of the rest of the members. So somebody asking, what is the interquartile range? The interquartile range is the difference between the upper quartile and the lower quartile. So it is this difference here. So in our case here is 15 minus 12, which is equal to 3. So what we are going to do is we are going to multiply this by 1.5. So will give us a 4.5. So a 4.5 okay. So what we do then is that we get the upper quartile, which is the 15. And then we add 4.5 to it. 4.5 to it. And this one will give us 19.5. So any value above 19.5 will be considered an outlier. So I think the value I gave you, this value here is 20, I think, not 19. This value here is 20. So 20, which is above 19.5, any value above that will be considered an outlier. When we come down here, you will have 8 minus, not 8, sorry, 12 minus 12, which is the lower quartile, minus 4.5. So if you take this one away, you get 7.5. So any value below 7.5 will be considered an outlier. But here, the smallest value is 8. So there's no value that is below 7.5. Above, wait a bit. Is that correct? Is that correct? Is that 12? Did I do the calculation right? Where is the 1.5 coming from? The 1.5 is coming from somebody gave us the standardized that value and told us that is what we need for the calculations. Okay. So we don't have any value below 7.5 because 8.5 is above that. So there's no value. So the smallest value here is 8, and there is no value below 7.5. So there's no outlier on the lower part of the graph here. Okay. Now, when we go to the salary, we see the same thing. You can see from here that the minimum salary, current salary is 15,750. The maximum salary is 135,000. The medium salary is 28,875. Then this is the lower quartile, and this is the upper quartile. Okay, so you can see from here that the least paid person earns 15,750. The highest earns that 135,000. So if, for example, we find a value here that the lowest person maybe is earning, say, let's say $15. So you begin to question that, I mean, can somebody work for a full year for $15? And you probably say, well, this could be an error. So one thing that by simply looking at the maximum and the minimum value, you will already be able to actually determine whether there's any error or not. Let me go to the chart. Anybody with it? Please explain the calculation. I thought I did explaining the calculation. So the formula for calculating the boundary or the upper point is 1 point, the upper quartile plus 1.5 times the interquartile range. What's the difference between quantitative and qualitative variables? Qualitative variables or categorical variables are variables that categorizes or put your experimental or your study unit in groups. So, for example, you can be either male or female, that is categorical or qualitative. But your height is quantitative because it can be measured over a scale. Okay, so I'm going to do the first thing is here. So here, let's look at the upper quartile. Our upper quartile here is 37,000. 37,050. That is our upper quartile. And then plus 1.5 times the interquartile range. Now, our interquartile range is going to be the difference between the upper quartile, which is 37,050, okay, minus the lower quartile, which is 24,000. So if you get that, that will give you the upper boundary. It will give you the value here. That is where this value will stop. Then we are saying any value above this will be considered outlier. So you can see there are very many outliers here. There is this particular value here. I think this is the value, the highest possible value here. But we still have a lot more value within here. And then, of course, you have your upper quartile, the lower quartile, you have the minimum value of the maximum value. The point here is then, are all these values really outliers? What is an outlier? So an outlier is a value that seems to be and does not seem to conform with the rest. But look here, in this particular case, we have all the employees of the company. We have the managers, we have the secretaries, we have all the office messengers and everybody else. So if you're going to group everybody together, some people may appear to be outliers because they are grouped with other people. But if you put the managers together, you're most likely going to reduce what you may consider to be an outlier. So this is the importance of trying to subset your data and try to make your summary maybe based on some value. So that's what Ellen was talking about yesterday. When you're trying to do those frequencies, you may want to do the frequencies based on the different categories. And this is where bringing in another variable so that your bivariate or multivariate exploratory data analysis would help in this particular case here. Okay. So outliers. So if you see here, we seem to have these gentlemen and ladies here who are a bit off the rest. So these are outliers. There are reasons why. There may be reason why they are out of the crowd. Maybe they are put out there by mistake, or because they have something different. They are unique in their own way. So outliers are separated from the rest. They are unusual value. So you may need to explore the reason why these values are different from the rest. Are they errors? If they're not errors, then yeah, they could be of interest to you. I mean, if these guys here are supposed to be in the crowd here, but they seem to stand out, then you need to know why they're here. Okay? Do they consider themselves to be different from the rest? So in practice, what always happens is then that first of all, you need to check whether these are outliers or not. If you confirm that they are not outliers, the practice is always to do analysis with or without the outliers, and then you can compare the results. The other issues here are what we call the missing values. So the missing values may also pose a lot of challenges when you're doing the analysis. So the main issue is, does the missing value lead to different results if the data was not missed? So you need to say look at what is causing the missingness. So if, for example, let's say we have just been in Uganda, we've just been doing our population census. Now, if, for example, later you try to match the houses, the homesteads, you try to match them with the data collection, and you find that maybe all the houses that all the families that appear to be far away from the road are not included in the census. So the question, the missing value in this case are very informative because there's a pattern to the missing value. But if the missing value is random in that maybe one household in among 2 or 3 is missing, and then another one, I mean, if there's no particular pattern, so in that case, you would treat that missing value without really having to bother. But if the missing value has pattern, then you may actually need to really get worried about that. So now, how do we describe a population, the distribution of a population? So the first thing is, there are certain characteristics that may be interest to you. For example, the center of the population. The spread of the population. The peaks, how many peaks do you have? And what about the shape? Do we have heavy tails? Do we have lighter tails? And what about outliers? So we're going to look at how we can use things like histogram and box plot to actually look at the distribution of the population that you're trying to study. Now, the first measure of the population that we are interested in, the first measure is the measure of central tendency. So we always want to know what is the average. How does a typical plan look like in a particular forest? How does a typical Ugandan look like? How does a typical Kenyan look like? How does a typical Nigerian look like? So that is the measure of the center. If you say, oh, a typical Nigerian male is about 1.8 meters, okay? So that's supposed to be fine for us, how a typical member would be. But that does not mean that there is you may not get somebody who is a male who is 1.2 meters. It may be there. You could also get a male who is 2.2 meters. That may also be there. But the most important thing here is we want to know the center. Now, knowing the center is important because then it will help us to determine how far away some values are from the center. Now, if you are too far away from the center, if you get a man who is maybe 50 centimeters tall, and the center for Nigeria is 1.5, then you begin to question this particular value here. I mean, you say this is really not a typical Nigerian man is supposed to be 1.8. Now, somebody who is 0.5, probably, if not a child, then this person could have come from somebody else, or this value could actually be an error. That's what you want. So there are two ways of measuring center. We have the mean or the average, and then we have the median. Somebody has just joined the class and saying which data set are we using? We are using the data set in my head today. We'll show you the data set that we're using shortly. Okay, so we need to calculate the mean. I think we all know how to measure the mean. There is also what we call the trimmed mean. What we know here is that the mean is affected by extreme values. So if there are values that are very far away from the center, they tend to affect the mean. Okay, so if you go to the current salary, for example, and then the years at school, so you can see that there is a big difference between the mean and the median. Remember, both of them are supposed to measure the center of the distribution. So these values here, these outliers here, tends to make the mean to be much bigger compared to the median. So remember, the median is you just align the observation from the smallest to the highest, and you look at the one in the middle. So the median is not affected by extreme value, while the mean is affected by our extreme value. So for you to get closer to the mean, you can do what we call a trimmed mean, but you can see here you need to cut off a lot of a bigger percentage of your data to actually get the trimmed mean. The same for school. You can see the difference between the mean and the median. What I tried to show here is that now if you cut part of your data off, you see the median doesn't change much. So the median as a center of measuring the distribution is very robust. That's the word is very robust. It does not change much with changes in the data. Because if we go back to these pictures here, so you see the median is you're interested in the middle here. So these heights here are the one that are the median height. So even if I chop up these people here, I chopped up these people here, the median is like to remain the same. So that's why it is not affected by extreme observation, because you can always get them off. Okay, so this is what I'm trying to show here, that the median at the center is very, very robust. Now, what about the spread? Now, the spread is a measure of how far values are from the center, from the central value. So we said a typical male Nigerian should be of height 1.8 meters. Let's say like that. So the question is, not all Nigerians will be 1.5, 1.7 meters. Somebody may be 1.6. Another person may be 1.2. Another person may be 2.2. So a spread is just measuring how far apart or how scattered these values are in relation to the center. And these are common method that we use for measuring the spread. We have the range, we have the variance, we have the standard deviation, we have the interquartile range, and then we have the coefficient of variation. So all these tend to measure the same thing, but they have different characteristics, and therefore they may be affected differently by, say, outliers and other things. So here, the easiest way to measure is the range, which is just the difference between the maximum value and the minimum value. Another is the interquartile range, which is the difference between the upper quartile and the lower quartile. So both the range and interquartile range do not take into account all the data points. So remember here, the range only takes care of this and that. It doesn't care about what is here. All these things here, it doesn't care. So you can have a situation where there's one value here, there's another value here, and then all the other value will be here. So if all the values here, so you can see that it doesn't really matter. The fact that there is no variation here is not really, doesn't affect for you your measure of the range, which only takes care of the extreme values. And then interquartile range, you compare the upper quartile and the lower quartile. That's what you have. So with our data, so the next one is the variance. So the variance is simply you're measuring also the variation from the center, how far each observation is from the center. So you can see that this observation here with a value of 6 is far away from this, is the farthest from the center, followed by that, followed by this, and then that. So here what we are doing is we are simply looking at the difference between each observation and the mean. Then you square, you sum them, and you average. And then the square root of that will give us the standard deviation. So this is what we have as a measure of the spread. That is, so like I indicated before, the spread is also can be affected highly by extreme values. So let's look at the two values here. So this is the range. Now, if I look at the entire data set, the range is 13, interquartile range is 3, the variance is 8.2, and the standard deviation is 2.88. Now, if I chop off 5% of the data from this extreme ends, this one changes to 11, it remains 3, this one changes to 5.3, this one is 2.3. So you can see here that the range is affected a lot by changes in the data. So it is not robust, but interquartile range is quite robust. But, okay, so you can see the value remain the same. And then the variance and then the standard deviations are also affected by changes in the data. So if you trim off part of the data, you see. So extreme value also have effect on the measures of spread, especially if you're using the variance and you're using the range. The variance and standard deviation are the most common method that I use for that. Okay. So the other thing that we're also interested in is to look at the distribution pattern of value in the data. So here, for example, we want to see whether there's symmetry. So when there's symmetry means if you fold this from the middle here, the parts should fall neatly on each other. So this is what we only call symmetric, and this is what we expect from a normal distribution. So this is also symmetric, but you can see that here the values are very tight, are very closer to the mean. Here the values are a little bit wider. Now, when you look at this other one here, you can see that this is not very symmetric. This tail is a lot longer. So this is what we call skewness. So you have the skewness. So the skewness can either be to the right or to the left. can either be positive skewed or negative skewed. And then you can also have a situation where instead of having one peak, you have two peaks. So here you have two peaks. So all these will determine the choice of tools of analysis. So if you want to do analysis of variance, for example, you expect to have this kind of distribution or this kind of distribution. Now, if you have this kind of distribution, then you may need to do something else to help with that. Or if you have this kind of distribution, then something else needs to be done. You either need to choose another tool for the analysis, or you do things like data transformation and so on and so forth. So let me go to the chat question. I know you're being answered in the box. Are we together? Okay, we are following. These are simple things. So the distribution, the shape of the distribution is mainly the pattern of that the values take, showing their differences relative to one another. So this is mainly observed in the like, for example, the histogram. So for example, the histogram will tell us that values tend to be close to a particular value or multiple values. So this is where a typical value would be. What is the typical value? It's the center of the distribution. So most values vary above that typical value. So let's look at this. So here, for example, for the distribution of the salary, the current salary from what we have there. So you can see from here that the most common values is here. Okay, so most of the values are here. Okay, now there are values that are very far away from the center. These are the unusual, the outliers, the unusual values. Okay, so the entire spread of the data, that is either from this side or this side, is what we call the variation. So you can see that most variation are found above the common value, and while on this side, there is less variation on this particular point. So you can see from here that we seem to have all these values here. That seems to be on their own, but this value here could also be because of maybe those who are highly paid. You have people like managers that get more money, so they could be the one on this side, and then the other common workers are the ones that are here. So here you may be dealing with more than one distribution. So when you're trying to explore your data set, you don't need to rush to make decision about whether the data is skewed or not. You also need to know what could be responsible for the pattern that you observed here. Because here we can see that there could be a number of people who get paid more compared to those ones who are paid less. And so you could be dealing with two populations. It could be a population of the managers and then the population of everybody else. So you can have a situation where there is no peak. You could also have a situation where there is one peak. So these are just normal, these are just generated using the computer. This is, for example, what we call a symmetric distribution with one peak. So you can see this is the left tail of the distribution. This is the right tail of the distribution, and this is the center. So here we can, for example, put this and say, well, we have a normal distribution here. While here, we have a non-symmetric with one peak. So this is our peak. We have the longer tail here. So this is the right skewedness, and then the shorter tail is on the left. We can also change, you can look at it in this form. So you can see here we have the right being a longer tail, and then this one, you have the left being a longer tail. So this will be shorter tail, and that will be shorter tail. So here you can have what's called left or positive skewed, and then here you can have what we call a right or positive skew. But all these should take into consideration that instead of dealing with one population, we may actually be dealing with two or more populations. So later on, you need to bring in those populations into your analysis, And once you bring the population into your analysis, you should then be able to determine whether is this need to model those differences, or there is no need for modeling them. So the box plot and the histogram literally show similar information. So this is the same data set. So you can see where the bulk of the box plot is. This is also where the majority of the data point is. You can see the outliers are identified here. So if you put them side by side, you can actually tell. So these values here are the values that we have actually here. The same with what we have on this side here. These are the values that are here, and then these values here are the ones that are here. So that is actually what we have there. I'm not going to talk about this for now. Okay, so these are some of the things that we can look at. You have the material with you. I'm just trying to scan through this quickly. This is negatively skewed. This is positively skewed. Negatively skewed means the tail is on the left side, on the negative side of the number line. Positive skewed means the long tail is on the positive side of the number line. And then symmetric means the two tails are uniform. So you can fold this one into two, and then you make. So here we see that the mean equals to the mode equals to the median. And here you see that the mode is the one at top, followed by the median and followed by the mean. So the outliers are here, while here the mode is still on top, then the median, and then the mean. So you can see that these values, these big values here, tend to pull it this way. That's why I said if Bill Gates joins our class here and we calculate how much money we have on average we have on our accounts, then we may all walk away from the class very happy that we are very rich because the average is very high. But the average has been pulled away by Bill Gates or a rich person in this class. So the next one is then when we are dealing with the issue of central tendency spread or skewness, this don't make a lot of sense when we are dealing with qualitative nominal variables. But for qualitative ordinal variables, sometimes it makes sense to treat the data as quantitative when you're doing exploratory data analysis. So here, for example, you have the Likert score or scale. Maybe you have a scale of 0 to 9, like what is done by people measuring diseases and what. So at the end of the day, these are ordinal scales. They are not really they're a bit qualitative. They're between qualitative and quantitative. So you need to handle them with some kind of a bit of caution as you move on. So let's look at briefly at how do we summarize qualitative variables? So how do you know that you have error by looking at minimum and maximum values? We make the assumption that you are an expert in the field in which you're collecting the data. And therefore, there are values that probably don't make sense at all to you. But you could also go and check. For example, if you're measuring height of school children, now you should be able to have a range which you expect normal values to fall. If the normal values are expected to fall between, say, maybe 70 centimeters and say maybe 1.2 meters. Now, if you're going to get a value of 1.8 or 1. Then you begin to say, but is this a child? Even an adult in this area probably don't have that height. So that's how you can actually tell that there's something wrong. So we expect that you as an expert, you understand what's going on. Okay, so from our list of variables, there are three variables that are qualitative. We have the gender, man or woman. We have job categorization. You're either a clerical staff, you're a custodial, or you're a manager. And then the minority classification. You're either a minority or not a minority, depending on how a minority is defined. Okay, so here the main tool that we can use for summarizing qualitative variables include frequency tables. This is very simple. We saw our frequency tables generated yesterday using the summary command. So you can have the frequency. So here, for example, can say 216 of the employees were female, 258 were male. So so we say probably about 55% of the employees are male. So somebody would already start saying, well, why are these people employing more male and yet the population of female and male should be balanced? So you can start your case there already. The same information can be shown in a pie chart. So you can see here male or female, or you can show it in a bar graph. So you can see from here that comparing a pie chart versus a bar graph probably gives us a better representation, especially when the values are very close together. So the eyes are not very good at differentiating circles, but the eyes can show us this. So from here, we can see that the females are few, the males are more in this company. Handling outliers, I thought I talked about that. So with outliers, the key issues are one, the first thing is you need to first find out whether there are errors, where there are not errors. If there are errors, you can still go back to the field and try to correct, or go back to the original data collection form and try to sort it out. If it is not an error and you confirm that genuine the value exists, two possibilities. The first thing is you can do analysis with and without error and compare the results. But in most cases, you can also say, well, if there's one outlier, what you could do, you could pick that outlier and handle it, talk about it separately while you analyze the other one and give different recommendations. If we look at the different job categorization, so you can see from here that the majority of the employees are clerical staff. You can see about 77% of the employees are clerical staff. And then there's about under 6% are custodial. Custodials are mainly people concerned with security and other things. So from the graph, you can see it's a lot clearer. So from here, we can see that the clerical staff are the majority, followed by the managers, and then we have the custodial. Now, we may then need to go and say, okay, now, is this in one way or the other? Does the job that you do influence the pay that you get? Of course, the answer is yes. But the extent to which it does, we may need then to bring the two variables together. You may bring the clerical, the job category and current salary. We look at them as a bivariate analysis or bivariate, so that you can tell that, okay, I think the different employees get different averages for the different salary. And that's going to be what we're going to look at next. So if you look at the minority classification, you can find that about 22% of people in this club can be categorized as minority. So you can present in a frequency table, you can present in a pie chart, you can present in a bar graph, or you can also just present it in a text. So if, for example, you have only two groups like this, you don't need actually to draw a bar graph or a pie chart or even a frequency table. What you simply need to say in this case is that this company's employees about 22% of minority, and then somebody will know that the rest are majority. So you have your 22 versus 78%. Okay, so that is looking at one variable at a time. Now we're going to look at the situation where we can look at two variables together, because the reason why you go to do a study is because you're interested in studying relationship. Now, studying relationship means you can look at two variables, three variables, or four variables at a go. Okay, so what we saw so far is that that we have three categories of employee. We have the clerical staff, we have the custodial, and then we have the managers. So the issue here is now that can we relate this distribution of the salary to this? Okay. The question I would be interested in asking would be, what kind of worker is this? Okay. Is this person getting 135,000? Is that person a manager? Is that person a custodian? Is that person a clerical officer? What about these gentlemen and ladies here? Where do they fall? Do they fall in this? Do they fall in that? Or do they fall in that? So I can look at these two together. So the question would be, is there a relationship between the current salary and employment categorization? So you can see from here these are managers, these are custodial, and then these are the clerical. So you can see from here that, of course, in terms of the median, the managers get a lot more money. Okay. The custodials are here, and then the clericals are there. So this is also a table that can give you that. So you can see that the minimum, the least paid clerical get 15,750. The least paid manager gets about double that. Okay. And then we can see that 75% of clerical get below 31,000. 75% of the managers get below 750, or you can say 25% of the managers get above 72,000 and that. There's the highest paid person is a manager, but there's also there are also some good clerical staff getting 80,000, the maximum. But these guys are actually well, their salary don't vary that much. You can see the minimum, the first quartile, the third quartile, the median, the third quartile, the mean, the third quartile. You can see the maximum. You see the values are very close together. So this is the kind of information that you actually need. You see, from here, we seem to have a lot more variation among the managers. Okay, so as a manager, you need to be able to negotiate your salary. So there are people come with different bargaining powers. They may have that. There's very low variation between our custodial. There's also a bit of variation within the different clerical staff. So these are the kind of information that you as an expert need then to convert it into your bring your knowledge in, and then you write a paper or write a thesis based on that. The other thing is also we want to see, are there differences in education among the different categories of the job? So you can see from here that, of course, the least learned manager took, yes. Okay, I'm going to talk about trim mean when we are doing it practically. Okay, so you see, for the custodial, for the managers, the person who studied, the least studied person is 12 years. The maximum is 21 years. Okay, and then the custodial is the maximum is 15 years. And then the clerical, the maximum is 19 years. So we can see that there's variation in the number of years spent within each job category. Now we want to relate the job category we want to look at the So here we looked at job category by salary, current salary. And then we also look at job category by level of education. So the question that one may want to find out is, can educational level explain the disparity in the salary? So that's one of the questions that somebody want to know. Can education level explain the disparity in the salary? So how much variation is here compared to the variation here? How much variation is there compared to variation here? How much variation is here compared to this variation here? Okay, so what we can do then, you can put this box plot for the two side by side, and you want to see whether there is actually some kind of a pattern. Okay, so if there's relationship between education and salary categorization, then the spread in the two should be similar. So here, for example, let's look at the current salary. So you see, these are variation in current salary for the managers. These are variation in current salary for the custodian. This is variation in the current salary for the clerical staff. Now, when we look here, of course, we can see the picture here slightly different from the picture there. But what we could do is we can put just simple coefficient of variation and see. So the value should be similar. So you can see here 28 versus 9. So you can see that there's less variation in education of the manager, but there's a lot more variation in the salary they earn. So this already raises question that apart from education, you need something else to be able to bargain a good salary. That's what we say. Now, when you look here, there's a less variation here compared to here. So what does it mean? So what it seems to hear is that it looks like differences in education doesn't really matter much when it comes to salary, when you're custodian. So if you are supposed to sit at the gate, it doesn't really matter how many degrees you have. Your point, your role there is to open the gate, close the gate, talk nicely to people, and so on and so forth, ensure that bad people don't enter the premises. So in that case, your education may not really matter that much because the job is standardized and you probably don't require much of education. But I'm not authority in that field, so I can't say much. Now, when you look at here, the current salary here, and this, well, we seem to see the similarity in variability, but still, a variation in education is not equivalent to variation in the current salary. So these are just some of the things you can scan through your data, and then you should be able to start actually thinking how finally the final story is going to come about. So now we want to look at the current salary of managers by gender. Let's look at the managers, male or female. Is there differences? Of course, we can see that the males have higher mean compared to the female. Is this because of discrimination? Could be. Could it be that the male managers are more educated? Let's look at that. You can see the average, that, and then there seems to be no variation in education of female. All the female managers have gone to school for about 16 years. The males, they have a rate of 17. They are actually male who studied up to 21 years at school. So you could say, well, maybe the managers who get more salary could be more educated than the female salary, but that's not all part of the story. But at least from here, this side by side, you'll be able to see something coming up here. Okay, so this is what I would consider. I would really consider that you put as much time as possible in your exploratory data analysis, because it's going to make a big difference in the step in which you're going to take to do the final analysis. I always spend much of my time doing exploratory data analysis, so that when I go now to try to do some modeling or what, I already have a lot of valuable information at hand. And while I'm doing this, I'm already I keep noting a little bit of things here, like, okay, there seems to be differences in education between male and female. There's differences in salary between male and female. There are more males who are managers compared to males who are female, to managers, female managers, and so on and so forth. Now, if we look at the clerical staff, education versus that, so you seems to see that there is apparently very little variation in education, even of clerical staff. But there are actually female that have studied a lot. They even studied a lot more than most. So you see, these two females have studied more than 75%. I mean, they above the male as far as studies is concerned. But they are not. They may not even be these ones here. They could be earning salary somewhere here, and those are the kind of thing you really want to dig deeper into, so that you'll be able to appreciate actually what's going on in your data set. Okay. So here what we can also do, we can actually look at relation between any two qualitative variables. So here I look at the job categorization. Here I look at the gender. So the question would then be, when it comes to job distribution, is there some bias? If it is bias again is which gender? Okay. Can I explain what is the source of the bias? Is the bias coming from education? Is the bias coming from the society itself, or where? Okay. So we can look at a joint distribution, and the question is always, is there association between job categorization and gender? Are male and female equally distributed in the different job categories? So this is where we have what called cross tabulations, and the cross tabulations, you can go ahead and even test the hypothesis. So you can see from here, if we are to look here, so you can see here that if you look at the clerical staff, you can see here we have more female as clerical staff compared to male. Okay. Now, when you look at custodial, there are actually no female who are custodial. I think this data set was taken a very long time ago, so it will be a taboo to get a woman sitting as the gatekeeper. These days, things have changed a bit. So all the 27 custodians are male. And then, of course, the gender activists would want to capitalize on this part here. This is where now you're going to see a lot of stories coming. So you can see that a bigger percentage of the managers are actually male. So out of the 84 managers, 10 out of 84 are female. So this is enough to bring in issues. Now, it also depends entirely on how you want to communicate. Somebody may communicate this way. No. So this is 10. I mean, somebody may look at it from this angle, or somebody may look at it from this angle. It depends entirely on what level of alarm you want to raise. So people who write newspapers, who do what, they know how to pick information. So the same information can be presented in two ways. One in a very mild way, another one in a very, very tight way. Okay. So here you have the frequency, you have the relative frequencies. So you can present the same information here. So you can see from here, this is the custodial, this is the manager. So there are no female custodial. So here you have clerical, there are more female clerical compared to so these are male. So you can see here, we can compare this. This is male versus female. This is male versus female. Of course, this is male versus female. So the key thing here is about communication. What do you want to communicate? So that's why they say statistics can be a statistician can be a liar. It's not a statistician can be a liar. It's not about lying. It's just trying to present the alternatives that is there. So your focus depends entirely on which information you want to pass and how alarming you want information to come. Okay. So those who have done analysis using SPSS, we always talk about marginal. So marginal is mean at the margin of the table. So here, for example, male and female, you can talk about the marginal distribution by gender. You can talk about the marginal distribution by but for clerical staff. So this is how we can present a relationship between qualitative variables. This is cross-tabulation. You can have cross-tabulation, or you can have two-way, three-way tables. The more way table, the more complicated it will become. Okay. So when you look at this, for example, what you can talk about here, for example, say all custodial jobs are taken by men. Okay, that's one way of looking at it. Or you can say the female are denied custodial job. I mean, it's the same information, but presented completely in a different way. You can say 88% men took 88% of the managerial positions, or you can say female took only 12% of the managerial position. Depends on what kind of bell you want to run. Women took about 57% of the clerical job. I saw a story in the newspaper yesterday. Was it yesterday? They say only 6 candidates from a certain regions were selected, and this 6 was out of 60. So when you look at it, we say, but if you look at it in terms of percentage, then you say 10%. 10% actually, if you consider that there are so many regions, 10% is actually a lot. So this person was trying to alarm by saying only 6 candidates were selected. But in the story, is that when you go deep in the story, then you say the 6 is actually out of 60, not out of 1,000. Because if it's out of 1,000, that would be different from it to out of 60. So this is a simple way of presenting your results. And I want to emphasize here, presenting result does not mean writing 20 lines. You can write 2 lines or 3 lines that communicates what you want very, very clearly. If you want to write 1 page on this graph here, then you're writing something else. You're not writing something useful. Okay, so finally, we are going to look at the relationship between going the next 10 minutes, then we go on the analysis. So the next thing is we want to look at relationship between different two or more quantitative variables. So initially, our quantitative variables were education level, current salary, beginning salary, time on job, and previous year's experience. So the question that one would be interested in would be, is there a relationship between the number of years spent at school and current salary? So do I need to, if I spend more years at school, will I get paid more? That depends on what you do at school, no? Does the current salary depends on the beginning salary? So if I bargain my way properly, certainly it will have an impact on what I will get. It depends on your bargaining power. Does the current salary depends on previous year's experience? Depends on what you are doing previously. Okay. So if you want to present two quantitative variables, the starting point is always what we call the scattered plot. So with the scattered plot, here one variable is going to be on the x-axis and the other variable is going to be on the y-axis. So in this case, it really doesn't matter what is on the x-axis and what's on the y-axis. But later, if you're doing regression, like what my colleague is going to look at from tomorrow, is going to be, if you're looking at regression, for example, then it's important to know what comes on the x-axis and what comes on the y-axis. Okay. So one or more additional categorical variable can also be accommodated in the scattered plot. So we are going to see actually how we can bring in additional information on the scattered plot when we start doing our analysis. So is there a relationship between level of education and number of years at school and current salary? So if these are the number of years at school, there are people who spend 8 years at school, 12 years at school, 14 years at school, 16 years at school, 17 years at school, 20 years at school, and 21 years at school. So among those who spend 8 years at school, this is the range of the salary that they get. Okay. And then those who spend 12 years at school, this is the range of salary they get. 14 years at school. So you can see this one spent 14 years at school, but there's somebody who spent 12 years at school getting more money than them. Of course, these are 15 years at school, 16 years at school, 17 years at school, okay? 18 years at school, 19 years at school. Then there is 20 and 21 years at school. So what you can see clearly from here that actually the people who spend a lot of time at school are not the best paid. See these three people here, they spend a lot of their time at school and their salary is in that range. Now look at this gentleman here. There is a gentleman up there. Spent 19 years at school. Okay. When these guys were still studying, a person already started making money and now they're far much up there. But that is not the point. The point is that there is trend. So we can see there is actually trend. Okay. So we seem to see there is actually some relationship. Okay. I pointed that already. So in terms of so you can see there are 53 people who spent 8 years at school, 196, 116, and so on and so forth. There's one person who spent 21 years at school. This person studied a lot, but is getting little compared to those ones who studied for 19 or what. So you can see the value that we have there. Of course, we can also look at the beginning salary versus the current salary. So we also seem to see kind of a trend going on that if you start early, start lowly, you also low. But there seems to be this gentleman here. He started from here. He is also at that point. Okay. So that is what. So there's also a positive trend there. Of course, there are these people here who started low, but they were able to climb very fast. Okay, what we are also going to see is that you can actually draw multiple scatter plots at once. These ones here, you can draw several of them at once. And then you can see from here that there is a relationship here. This is the same as this one here. There is no, or you can see here, there seems to be no relationship, no relationship, no relationship. Of course, we can see that is what we call highballing. we may need to get some figures in. So we can go ahead and bring in some values. That's where we look at things like correlation and so on and so forth. Now, one thing I want to also note here is that sometimes when you want to run or to draw a scatter diagram, now it's always important to take into consideration the fact that you're dealing with different categorization. So it may be important either to use color to show the differences between the different groups, or you subset your data and draw histogram or draw scatter diagram for the different groups separately. So if we look at female managers only, you can see literally that there seems to be some relationship here between the beginning salary and the current salary. There's some small relationship. But for everything else, there seems to be no relationship at all. So apart from where you started from, once you don't gain any advantage either because of education or what when you're female. That is what you can look at from this, that. But that is entirely depends on the expert in the field to explain what is going on. Now, when you look at the male managers, you seem to see this relationship is there. There are also maybe this bit here, but there's something a bit there, but also the rest you don't seem to see also the relationship. Now, when you go to clerical, we seem to see this relationship existing, nothing really going on. Custodial, nothing seems to go on. So based on the high alone, it may be a little bit difficult to actually tell what is going on. So the best we can do is probably to go and look at what we call correlation. So correlation will tend to give us the strengths of a linear relationship between two or more variables. Now, Susan is going to talk on this more, but I just want to show you as part of the exploratory data analysis what really happened. So here, the correlation falls between -1 and +1. This is a perfect relationship. So 0 is when there's no linear relationship between them. So if a value is close to +1 or close to -1, then you say there is a strong linear relationship. If it is far away, it's closer to 0, then there's no linear relationship. There is a possibility of having other relationship, but the linear one is not there. So when we look at current salary versus beginning salary, you can see 0.88. So this is close to +1. So that means there's a strong positive relationship between the beginning salary and your current salary. That means if you start low, you'll also earning low. So the higher you start, the higher your next salary will be. So that is a positive trend going in that direction. So if we put it in for all the observations, so we can see there is a relationship here. There is a relationship here, 0.66. There is a relationship here. And then nothing here, nothing there, something negative here, but nothing, there's something negative here. So these are the different relationships that you actually have. Now, of course, you need to be able to understand. The first thing is you need to be able to interpret these values. What do they mean? And then from there, you should then be able to say, well, this is the value means this, but based on my knowledge or based on what on the theory that I have, this makes sense or this doesn't make sense. Now remember, this one is based on all the observation. Now I may want to see the correlation for only managers. I may want to see relationship for only female managers or male managers. Now the subset you select to observe will depend entirely on your own knowledge or how you want your story to be. Writing a thesis or writing a paper is about storytelling. So you need to have a rough idea what kind of story you want to tell, and then the statistic will come and help you to tell that story. If you don't have a story to tell, the statistics will not give you anything. I promise you that. Okay, so here, if we look at, let's look at just simply the correlation between the current salary and other variables for the data set. Now, for the entire data, for the combined data set, okay, so you can see that there's a strong relationship between the current salary and the beginning salary and education. So these are two positive relationships. Something strange also coming up here, telling you that actually your previous experience may actually work against you. It has a negative correlation. I don't know what that means in terms of employment, but it could be related to technology changes and so on and so forth. Now let's look at the managers. If you look at managers alone, you see now we see beginning salary and current salary is still strong. But education now doesn't seem to have a strong relationship when you're dealing with managers alone. For clerical, is also reduced. For custodial, it's even negative now. So if you seem to have gone to school too much in school, you seem to lose out for the custodial job. So you can see from here that the relationship between the current salary and the beginning and the current salary and the beginning salary, let's look at one at a time. If you look at this, the relationship changes also depending on the group that you're dealing with. Now look here, for custodial, there's actually no relationship between the beginning salary and the current salary. So you can see all these. Now, what is clear from this table is that don't rush and run your correlation for the entire data set and stop there. You may want to do correlation for the different subsets and then see whether something is going on. Now, like here, for example, if you're clerical staff, the more experience you had in your previous job, the less likely that your current salary is going to be. The question would be why? The same for the manager. We seem to also have a manager here that if a female manager had more previous experience, is likely to be paid less, having to have lower current salary. And then previous year's experience seems to have no effect on the male managers. It seems to have negative effects on the clericals, both male and female. Now, these are now the things that should be tickling your mind as a researcher and say, oh, what is going on here? Okay. Yeah. So this is where we are going to stop for now. I want us to rest. By resting, I'm going to be asking you a few questions in relation to the data set. Yesterday, we gave you the material for day 2 and day 3. So let's go to the chart first. How many people have downloaded the material for how many people have the folder with exploratory, the folder with the name exploratory?
Thomas, tell them to download the zipped folder. Some of them are saying that data is corrupt, but within the zipped folder, the data is there.
Okay. So you need to go, there's a zipped folder. You need to pick that folder and unzip it. Somebody said they cannot open. Yes, you need to unzip the folder. It's not opening, you need to unzip it. You don't need to open the PDF or the what now. So can the link be shared so that people download, those who have not downloaded? Now, don't write anything. Now we're going to share the link. Okay, the link has been shared. Please download the material. If yours is disturbing it, download again. Okay, download. I'm going to show you the content, what you are supposed to have in that folder. The link has been shared again and again. Okay, what I want is that I want you to, these are the content of the folder. The name of the folder, exploratory and influential. If the name is maintained by our colleague, Ellen was the one who shared that. So I want to know how many people have the content that I have here. Okay, I can see no script. The script is there. The script ends with explore.r, capital R. See, the script is the one, check what I have there. The script is the one, exploratory data analysis.r. There is no way you can have a folder without the script. The script has to be there. So I want you to get that folder and put it somewhere. I want you to put that folder. If you're not very sure of what has been going around and you want it safe, play safe now, carry that folder and put it on the desktop. The script should be inside, please. How many files do you see in that folder? There is algeriawit.csv. There's exploratory data 20th May 2020.pdf. There's exploratory underscore data underscore analysis.r. There is factorial.csv. Unless your system decide to delete it, that thinking it is a virus. Don't tell me it is empty. It's not empty. No, I don't have the. No. These files are not damaged. Unless they're corrupted from your own computer. So those with only 8, please check, try to download again and see if you can get all the 9. At least the majority have. Yeah, so I generated my, I'm using a Mac. So there are 2 folders, there's another folder within the folder itself. Okay, anybody who claimed he cannot get to you can be promoted to share the screen and we see. Who wants to share the screen? Who is having a challenge to share the screen and we see what is there? Aile, you say you cannot get the screen?
Maybe they can share and we see what the problem could be.
Aile,
But
can you
hold
share?
on.
Can you allow Aile to share? I also want to see the face of my former student if he's the one. I can stop sharing.
That person is not yet put up the hand. It's called who?
Haile, can you put up your hand and you're promoted? Anybody with a problem, please put up your hand and we're promoted.
Okay. We've promoted Haile.
Haile, can you share your screen?
He's joining as a panelist, so he should be able to share his screen.
Okay, okay.
What happened to him?
Is this sharing?
No, not yet.
Okay, let's hold on a bit. Say could not be able to display.
I'm promoting him, but he's not accepting to be promoted. Let me just pick another person. He is there now. He can share.
Okay.
Haile, you can share your screen. We have also promoted Prince Maroa.
Okay. Okay, he's starting to share.
Who declined?
No, he's trying. Somebody's sharing. We can wait. Okay. Okay. So where's the folder? Okay. Click on that one. Okay. Go to the next one.
Thomas.
Yes. Okay, please. Yeah. What you want to do is you copy all these files, copy all of them, and go and create a new folder and put it on the desktop. Create a new folder. Just say day 3. Okay, you put the content inside. Okay, just paste inside there. Okay. Okay. Now what I want you to do, okay, that's fine. Can you open your other file that we started with? I think now you have all the file. That's okay now. So, but I want you to go back to where we started from. I want other people to also see. Close that one. Yeah, open your file where you had it before. Okay, so now look here. There is a day 2. When you open inside there are 2 folders. Not that one. Go back. Go back. Yes. Okay. You see now I use the mark system. So you may have 2 more files in. That the second one. Okay. So what I want is to show is that the folder could be empty, but there are many folders in. So you need to look for the right one. The one with a dot, these ones here are corrupted files. They're not the one you're looking for. So you need to look for the right folder. There are 2 folders there. Why don't you get yes, open that one. No. First start the process again. What I want to show is that if you download that folder, because I use my computer, I use a Mac, so it tends to create another image, a folder image that may not have the content. So either you can use that day 3 material, you can now stop sharing. So if possible, I want everybody to create that folder on the desktop, and then you'll be ready to use it. You should be able to have 9 different files within. You can stop sharing now. Any other person who needs to share?
There is Prince.
Okay, Prince, can you share so that we can start?
No, it's sorted. Thank you.
Okay. Any
it
other
was because
person?
of the other folder which was hidden somewhere.
Okay, good. So any other person who has not yet done so that we can help? So Amolo Abat, you say you're only seeing 8. Can you share your screen? Amolo Abat, can you promote?
We have promoted Stephen. He had raised his hand.
Okay, Stephen.
None of it. We promoted him. Okay.
You got 9, but 1 is empty. 1 is not opening. Which one is not opening? Okay, Stephen is sorted.
Amolo has been promoted.
Okay. Amolo, can you share your screen?
He said I sent Helen into.
Okay. After that, I'm going to.
I'm not seeing what to share from.
Go down under. There's a green thing with an arrow below.
The arrow is pointing up. It has a word share screen.
Yeah.
So just click on that. Amolo, have you seen it?
Yes, I've seen it.
Okay, you click on share screen.
It, but you select the. Okay.
Okay. Okay, can you go back to where you get the file you got that from?
Those are the files I managed to get.
No, you go back where you got it from. There's another folder, you picked the wrong one.
Let him go to the Google Drive link.
I think he has it already on his computer. Can you go to your download folder? Hey, are we together? Amolo? If you have these ones with the dots, if you have this one with dots, that means you open it. There are more than one folder. You go up and open the one without the dots. Amolo, can you go up again and go to another? Hey. Okay. I think now we have lost him. Okay, so what I'm going to do, let me share my folder again. Okay, so I want you to open your folder. I want to see these files here. Okay. So we have the file that ends with extension .csv, CSV. Then there's pollination 2. Pollination 2 doesn't have the CSV, that's the text file. So it's supposed to have .txt. Then we have the PDF, that is the presentation. And then we have the .r, that is the .r is the .r is the script. So I want you to click, right click on the explore, on the one with the .r, and open with RStudio. Just click and see what I'm doing there. Have we opened? Okay, I want you to see the screen. Look at my screen. Have we all opened the script? If it can't open, that means you're not opening the right file. Okay, can I get, okay, can I just get only those who have failed to write? If you fail, type 1. Okay, for among those ones who fail, can you one of you raise your hand up and tell us and show us what you're trying to open? Joji, Umutuyimana. If you don't have the file, you have to run to Makerere and pick it from here now.
I have promoted the Boniface.
Okay, Boniface, can you show us? Let me end and stop sharing. Boniface, can you show us your screen?
Hello, I've not failed to open,
Eh.
but I just wanted to let participants know that maybe at their end, they are double clicking to open it. So they should right click.
Okay.
And then choose the application to open, which is RStudio.
Okay.
That could be the challenge. Yes. Thank you.
Okay. Good. Thank you. Yeah, if you open and you say install Agricola, say yes, you can click on install. That's okay.
We have promoted Takuzwa.
Yes.
Takuzwa.
Yes, just one person now. If I see what is happening, I know somebody say I'm using the old one, which is true. Because I'm old. Okay, one person to show, then we start. Otherwise, we are not going to do anything. We are going to form coalition of the willing. The data set are in the folder. So if you have the folder, you have everything. Yeah, somebody puts it right there and justifies the mean. Okay, so I think we are going to stop the process and I'm going to start running. Let me share my screen again. Okay, so the first thing is we have all installed R and RStudio, and then as Ellen was saying yesterday, you need packages to run the analysis. Now with packages, there are two things. The first thing is you need to install the packages. Now, if you have already installed the package once, you don't need to install it again. So the first step is install the package. Now, if you already installed the package, the next step would be to call that package in so that you can use it. So the first thing is, I want you to run line number 3. Line number 3 here, say library cars. I want you to run and tell me what you see. Mine says loading required package, car data. How many? There are people who say there's no package. Okay. For those who say there's no package ARA, no package car. Okay, let's stop now. I want you to go to line number 2. First, listen to the instructions. Stop writing. I want you to go to number 2 and remove the ASCII. Can you remove that and run that line? Install.packages car. So if yours tells you library car not found, that means it has not been installed. So you need to install it. Please don't just say error. Error, there's all sorts of errors. Okay, so you need to install the library, install.package cars. Okay, and then once you do the installation, then you can try to run the library again. Mohammed, you first installed the library cars. Look at my line number 2. And run line number 2. Remove the first symbol, the as symbol, remove it and run the line. Only install the package when you run line 3 and it shows you an error. So if it is successful, that is okay. Okay? Okay. So let's go and run line number, what you do, run line number 5. If line number 5 shows you error, please, you can run line number 4, which is the psych. Okay, so you can repeat for all of them. Okay, so can you run line number 6? So the first thing is, if you're not sure whether you install or not, first run 7. If you see error, then you go and run line 6. You run 9. If you see error, you go and run 8. Run 11. If you see error, go and run line 10. Run 13. If you see error, go and run line 12, and so on and so forth. You may not need all this now. Okay. So I'm going to give you 5 minutes to run all the line until line number 19. How many people have run successful up to line 19? Yes, if your car, if the car package successfully, you continue running. There's somebody still asking that we go over from loading. Yeah, but said that you can wait for it to run. So we're going to take a few minutes to run. And then if your script cannot open, that means you are in the wrong folder. First, look for the folder. Look for the right folder. If your script is not running, then you're in the wrong folder. Go and try to look for the folders that have files without what do I move my screen? Do you see my screen well now? Okay, there are those ones who have finished all. Okay, 3 more minutes. You try to help them first. Let me I need to scan something and send.
Hello? In case you get a message that package required, that means that you haven't installed the package car. So make sure that you first install the package before you load it.
Someone is asking that they don't have a link to RStudio. Thomas, over to you.
Okay. Helen, can you post the Google link in the chat? Someone wants the Google link. Now, if you don't have the link to RStudio, go and type RStudio in Google and then click. You will see download information coming up with the link in that document, and then click on download RStudio, either for Windows or for Mac or for any type of laptop that you have. Thomas is coming back. I'm taking over briefly as we see that people can load their packages, and also after loading the packages, in case you get an error that say that loading required package, that means you've not actually installed the package. So make sure you install the package. Go through the list and install the package first. Also, if you cannot access your data, that means you've not set your working directorate. But let's make sure that we are comfortable with installing the package and loading. Okay, so in the chat, is everybody comfortable with installing and loading packages? Let me see yes or no. Okay. Helen, please send a link to the Google documents. Send it like 3 times or 4. So whoever hasn't got data set, please, the Google link has been shared by Dr. Helen. Just copy it. Yeah, you can even put it in Google and run it. Will give you the documents, or click on it and you go straight to the folder. How can I update my RStudio into the latest version? We dealt with that on the first day. Dr. Helen did that, but if you want to update, you have to download a new version of RStudio, then install it, and then open RStudio, and it will be updated automatically. If you click on the link, you have to unzip the folders in order to access the data in the folder. Masked is not a problem. Masked means it is hiding behind something else, but you try loading that package and see whether it runs. Yeah, if it has successfully unpacked, it means it has been installed and it has been loaded on your computer. It's ready to use. Installer R is also a package that is used for updating R. I'm just looking at the WhatsApp chat. The chat to see the queries of the participants. But if you need a longer answer, please use the Q&A, and my colleague, Dr. Helen, will be answering some of those questions in Q&A. How do you unzip? Just double click on the folder and it will ask whether you want to unzip. Error, there's no package car. Please install it afresh. You have the old version. 4.33 is the old version of R. You will need to update later after this session. The current version is 4.4. For you to know whether RStudio has been updated, go to Tools and check for Package Updates. Then it will tell you whether RStudio has been updated. I've seen this message of link for WhatsApp group. Whoever developed the WhatsApp group, can you please share the link? Adawela, you are talking of installing packages. Which package? The car package? If you want to install a package, go to your RStudio window and type install.packages in bracket, inverted commas, car, close bracket, run that. After running, if it is successfully, then type library in bracket car and run again. Then the package will be installed. Okay, back to Dr. Thomas. He's going to take over from there. Thank you.
Thank you very much. Okay, I think now we can continue running the commands. Thank you very much, Susan, for stepping in. Okay, so what we are going to do now is, yesterday, you are taught how to set a working directory. So we are going to continue with that. So I want you to, you need to know where you need to know where your folder is. So let's go, we want to set a working directory. I'm going to show you one way and later I'll show you another one. So can we go to session? Click on session up. At the top of the bar, there is RStudio, there's file, there's edit, there's code, there is view, there's plot, then there's session, and come down to set working directory. Then choose a directory. Just see my screen. Session, set working directory, choose a directory. Are we there? You click on that. So look for where your file is. Mine is on my desktop under forum training and then exploratory. So you put a cursor on the folder that you want to make your working directory, and then you click down open. So if you click open, you should be able to see, can you tell us, can you see a comma on, you need to look down. You need to look down in the console. If you see something, set working directory, and it gives you some command. Let me see what is in the chat. Can you type what you've seen in the chat? What do you have in your working directory? That one is good. Okay. I want you to see, look at the R console. Look at my R console, look at mine. Mine is here. Mine is telling me set working directory, a double quote, a tilde, desktop, forum training, stroke, exploratory, and inferential. If you have any query, put it in the Q&A. It will be answered. I just want to see what you see on your R console. Please stop insisting on putting your number and talking about WhatsApp. We can do that later. We are going to ask the forum to give you 5 minutes to sort out the WhatsApp issue after the lecture is done. Okay? Anybody with a challenge doing that, can you raise your hand up and they give you options? Put all the 9 folders in the working, the 9 thing in the working directory. Can anybody with a challenge, can you please raise your hand up so that we can help? Francis Mirara. Okay.
We promoted Francis.
Yes, Francis, can you share? Let me stop sharing my screen. Francis, can you share your screen?
Oh, nice.
Okay, the nice baby, but what we went, you need to share the screen with the folder on. You have many things when you ask sharing the screen, you need to select the one. Select another screen to share. You have many screens there. Now let's first leave the screen, the packages for now. What we want is we want to have
Is it
is there, can you show for us the folder? Or show for us your R Studio.
Can you talk and tell us what is?
Yeah, you tell us what is the yeah. Just talk now. Unmute yourself and tell us what is there.
Okay, I cannot be able to load the data. If I go to session and new session.
Not new session, go to set working directory.
Sorry.
You go to session. You tell us what you're doing so that we can direct you.
I choose the working directory. My directory, yes. I already saved the data in the on the desktop. And
you need to create a, did you create a folder where you put those data in?
Yes, sir. Is this one written day 3?
Okay, you click on the day 3, don't open it. So what you do, you go to session, go to set working directory, choose a directory, yes. Go to desktop and click on the folder, don't open it. Don't click double to open it, just click on it, make the cursor on it.
Yes.
Then you go, the what is written down as open, you click on it.
Okay, thank you.
Okay, good. You can stop sharing now.
He was not sharing, he was
okay.
The baby.
Okay, any other person who wants to share the screen with the challenge? We are not using an Excel file, please. There is somebody with anonymous. Check if you're appearing as an anonymous attendee. Can you share? Can you be promoted? There's an anonymous attendee.
I've promoted Emily Draru.
Okay, Emily, can you share? Yes, we are setting entire folder as a working directory. A working directory is like where work is going to be done. So you're telling Ara, if you're looking for a data set, look within the working directory, don't look elsewhere.
Yes, you promoted me, but I already fixed the problem.
Good then. Okay.
Yes. Thank you.
Okay, so let me now go back and share my screen. I'm now going to go and start the analysis. You cannot see the session. Who is that? Can you? Paul, can you promote Paul? Paul Zinda. Zindo.
Zindo.
It's very important that you are in the right folder, then things will move very fast. If you are not in the right folder, things are going to be very messy.
He is joining as a panelist.
Okay.
Yes, sir.
Okay, so can you show us your screen or tell us what is going on?
Try and share it. I failed to find that.
Do you have the 4 windows?
Yes, I do.
Can you go up on the last? Do you see where arrest on the uppermost, the bar on top? Do you see anything on top? Try to put your cursor like you're getting it out of the screen up.
Yes.
Do you see R screen, R Studio file, edit code?
Studio. I'm also using a Mac.
You're using a Mac, yeah. Do you see where the Mac sign is? You see the small apple up at the right left-hand corner?
Yes.
Do you, next to that apple, there must be a word, just R Studio.
R Studio, yes.
The next one is file.
Yes.
Edit. You see edit?
Yes.
Code?
Yes.
View?
Yes.
Plot?
Plots, yes.
And session?
Yes.
Yeah, you click on the session.
Okay.
Do you see set working directory?
Yes.
Choose a directory.
Yes.
Then you look for where you fall in, put on it, and then click open.
Oh, okay.
Okay.
I put the whole folder.
You click on the folder itself, and then you go click the other one, open. Highlight the folder before you click open. Don't double click on the folder, because when you are inside, then you can it has to be on the folder, not inside the folder.
Yes, it's well now. Thank you.
Okay,
sir.
great. Okay. Now, what we want to do then, what you can do, you can copy that command that is reflected in the R console, and then you put it on under your command, so that next time you can run that line. Now you don't need to. So you see my line number 21. Do you see my line number 21? I hope I'm sharing my screen. I'm not sharing. Okay, sorry. Do you see my line number 21? If you see my line number 21, please copy your command from down and put it to replace my line number 21. Replace my line, this line here, with your command, the one you copy from the console. Okay. Okay, so now I want us to use the next 20 minutes. No one is attending to Bosede. Can you help Bosede? He said he can't open a file. Bosede Adeyemi. Can you let this one be the last person now we can promote? We can run the last 15 minutes, run the file, and then tomorrow pick it up and finish it up before we hand it over to. But it's dragging a lot too much. Can we see the person showing? This step is especially very, very important. Why this is important? Because in most cases, you don't need to be very perfect at writing code. What you need is you need to be able to get somebody's code, modify it, put your data in the right folder, make that folder your working directory, and everything else will work perfectly. That's why I'm stressing this. Okay, good. I demonstrated. Okay, so I'm going to demonstrate again. Okay, so what I'm going to do, just look at, sorry. Just hold on a bit. Okay, so I want all of us to go up on session. From session, you go down to set working directory and choose a directory. So that's how we set a working directory. You go to session, set working directory, choose a directory. Please go to Q&A and people will help you there to download the material. Okay, so we go to session, set working directory, and choose a working directory. Then from there, you go to where your directory is. So you put the cursor on the folder, not inside the folder. Okay, so for now we are going to run. So I want us to look at my line number 24. Can you run my line number 24? I have a question mark, and then I type the word Irish. I want us to run that line. What do you see? So you can see on the lower right window, it tells us that we are talking about Irish data set. It tells you that Edgar Anderson Irish data set. It describes for you the data set. So this is one of the data sets that we have in R. And this data set is available for you to use to practice. So when we are teaching R, in most cases, we use the data set that is inbuilt in R. So we're going to start with that, and then later we're going to call our own data set. Okay, so can we run the summary? Okay, so I'll run the summary. Let me go to the chart. Okay, so what is the minimum observation? Can you type the minimum observation? I see what you've seen. 4.3, okay. The maximum? Okay, good. Yeah, so here is, remember we talked about the 5-number summary. So here you have the 5-number summary. Okay, thank you. You can stop now typing. I've seen all of you got it correctly. So this is the 5-number summary that we talked about, include plus the mean. So the mean is also included there. So from here, you can see that the mean and the median are very close together. Now I want us to run line number 26. So line number 26, we are trying to plot the sepal length versus the sepal width of Irish. How many people are seeing a graph? So let me, okay, I can see, good. Okay, great. Let me stop this and share another screen of mine. Yes. Okay, let's first wait. We can continue installation later. I want us to first look at this. So you can see from here, we talked about the scatter diagram, a scatter plot, and here you're talking about two variables at one. So you can see here we have the Irish sepal, which is on the x-axis, and then the sepal width and sepal length on the y-axis. Do you seem to see any relationship between the two variables? Let me see on the chart. Are there a relationship between the two variables? No. Okay. Okay, so we seem to see no relationship between the two variables. Now let's, we're going to improve on, let's run our, okay, let's run the second line, line 27. Now okay, let's run line 27 and we see what happened in line 27. Okay, so we can see from line 27 that we're able to put in color. Okay, now the colors show different species because there are three species here, so there are three different categories. So when you look here, for example, you can see that the one in black seems to have a very good linear relationship between the sepal length and the sepal width. If you see only the one in black. Onkoni, you can unmute yourself and tell us what is the issue. First, tell us what you want to share, then we can we can allow you to share. Okay, so what we can see from here that apart from the simple plotting the two variables, the sepal length and the sepal width, we can also color so that we have different colors for the different variables. So this is one of the powers of ARA. This is where ARA excels. I still see some no's. I don't know no for what. How do you know which one is sepal length and sepal width? No, don't worry about the key for now. The keys will come later on. You can see down here, you say Irish, then there is a $sign, then there's sepal length, and then upper one, we have the sepal width. That's how you can know the difference. But what I want you to know in this case is that we can plot two variables, and then we can bring in a third variable, which is the species, which is a categorical variable, to actually differentiate them. Now, ARA is very, very good as far as graphic is concerned. So we are later going to see how we are going to complicate these simple graphics here until when you can write your title, you can write you can change the different symbols that you want to use. So for now, let's first try to enjoy what we are seeing here. Okay, so can we run line number? Okay, so we let's first run the line, then we can begin to look at so let's look at line number 28. So 28, we are looking at the sepal length and the petal length. Okay, let me first stop share. Okay, let me share I want to zoom. Then I can share the Zoom one. Okay, so you can see for sepal length and petal width, you can see that we have two kind of relationship. We have the red and the green seems to have a good linear relationship between the sepal length and the sepal width, while the species, the third species seems to have, first of all, the third species have a very, the petal lengths are very short. You see, almost all the values are below 2. While the other ones, the values run from 3 up to around 7. You see, this is the information that the coloring will bring in. Now, if you don't color, you seem to see kind of a relationship that may not really fit that well. And if you remember the correlation, how many people are not seeing my screen? How many people are not seeing my screen? Yeah. Okay, I'm going to redraw the graph. Okay, so here, what you can see here is that we have our window where we have the commands. Then below the command, we have the R console, that is our second window. And then our third window, we have where we have the environment. And then the fourth window is where the graph is being shown. So you can see from here that on the fourth window, that is the fourth window, that is the lower window on the right, we can see sepal length versus petal length, and we can see that there seems to be two relationships here. There is the black one and then the other two. So the species that we are dealing, the three species that we are dealing with seems to behave differently. Okay, let me go to the chart and then please help with what is wrong, what could be wrong. So Janella, can you promote Janella CB to share the screen, the last one, so that we can conclude by looking at what is on the screen. Janella, can you share? Can you promote Janella to share a screen?
Janella. Is it Janella?
Zanella, I don't know. Z-A-N.
Janella. Z-A. Zanele.
Zanele. Oh, Zanele, not Zanella. Zanele. Zanele. Sorry.
Okay, I'm promoting it to yes. Zanele is joined as a panelist now, so she should be able to
Okay. Oh, let me stop sharing first. Okay, can you share?
Go ahead, Zanele.
Yeah, and then Amito, after we need to get these people 5 minutes to sort out a few things on their Zoom. You always close very fast. So the first thing is, Zanella, you see here, you see on top, there is that packages, Agricole, Cars, Adobe, and others are required, but not installed. You see, you can actually say install. You can click the install, and then you can install those files. But for now, first show us what you have. Okay, can you run that line 26 and we see?
Can you see my R?
Yes, we can see.
Okay.
Yeah, can you run your line 26? You don't need to highlight, you just need to have the, I don't know, something seems to be wrong with your graphics.
I don't see anything.
Okay,
So
can you first, can you
my...
click, can you go on the side of the, No, go on the lower, on the fourth window. Can you click on the package? Can you click on the package up there? Click on that. Click on the help. Click on the help. I want you just to try to click a few things up and then maybe we try to run and see what's happening. Okay, you go back to the plot. I don't, try to run again and we see. It looks.
It's empty. I don't get any plot.
Okay. I think this is, now what you do, first install, click the installation and then the install up there. No, look at the warning line, the yellow line, the green yellow line. You see the yellow line with the warning on top? On top of the script, on top of your script. Immediately on top of your script.
Yes, I see it. I see it.
Can you click the install part of it there? Click on that.
I've clicked on it.
Yeah, just click on it and let it install, and then we sort out the rest tomorrow. Okay. You allow it to install those ones, and then that's fine. So what we are going to do, I request you ensure, please, this is your assignment. Ensure that you have installed all the packages, and then make sure that you are able to set a working directory, and then try to run the lines that we have here. Run them, don't worry whether you get errors or not, try to run them. And then once you get an error, try to look at the error and understand what the error could be telling you. So we will pick this up tomorrow. We need to run this, and if you can run the whole thing, that I would be very, very happy with that. So I request that you are given 5 minutes so that you get the link to the WhatsApp group. I'm also not on the WhatsApp group. I'll give my number to one of my colleagues to give to the person who opened it, so that I get also included onto that, or I'll try and see. So please, let's have 5 minutes to try to sort that one out. Then we can call it a day. But tomorrow we are going to pick up and run this slowly until we reach the end. Please remember, there's YouTube channel you can go and follow. There is a lot of material on the web. You can go and follow. Okay, so yes, please.
It's done installing, but still the plots are not showing. So I'm not sure what the problem now.
No, first close it up, and then we can redo it again, and then we see. But I need to check. Okay. Probably it could be related to some graphic issue with your computer. Okay, which computer are you using?
I'm using a Huawei version computer.
On a Windows.
Yes, Windows.
Yeah, what you can do is go on Google and then type I cannot see my R plot. That should be able, you will see a lot of, they will give you suggestions of what you can do.
Thank you very much.
Okay. So no giving up. Take your time, and slowly but surely we'll be there. But following the instruction is very critical at this point. So you have 5 minutes to sort out the issue of WhatsApp. Or one person could collect the numbers and give it to whoever does. But the link has been shared. You have to just click the link, and then you can have it. We are going to see how to save the script. But if you know how to save your file on Microsoft, What you can do? You do the same thing. You don't. Can this person who calls him or herself anonymous? I mean, you did not sign in. Just say some word. I mean, we can have a look at. You can say. I mean, you seems to be having some challenges. Can you talk for like just unmute yourself? Unmute yourself and tell us exactly what challenges you're getting. Is there any way one can retrieve the console without running error? Okay, the whole thing here is that once you have your script and your script runs, you don't need any other thing. You can keep your script and run it again and again. Okay, so tomorrow you can save the file the way you do your normal, the way you save your normal Word file or Excel file or whatever it is. But tomorrow I'll demonstrate how that is done. Please make sure you have this. You have the folder by tomorrow. Go and collect. Go and copy all the content and create your own folder on the desktop or somewhere where you can access it very easily. You can also post your problem on the WhatsApp, and then your colleagues should be able to help you. Okay. Please, somebody is dying to be on WhatsApp. Please help. Okay, so bye-bye, everyone.
Bye. Thank you for being good participants. We see you tomorrow.
Thank you.
Thank you, Ellen. How are you?
Very well, thank you. Thank you for the work well done.
Ellen, stop hiding. I don't know, are you in the kitchen or in the...
Today I'm hiding.
We want to see you.
I'm here.
We are used to being together. Now you try to leave us.
Anytime. Anytime.
I can't hear what she's saying.
He needs to set the date for the new one.
Okay, they're going to, I think they're going to. Hi, Susan. Hi, Thomas.
I have to put the schedule. Yeah, it's okay.
All right. It's always great seeing you guys.
Yeah.
Nice to see you. You better bring me some cheese.
and chocolate.
Okay.
I'll bring.
Yes. Good evening.
Good evening, Sue.
Oh, it is good morning.
Yeah. All right.
Okay.
Bye-bye.
Bye.
Regards to all.
Okay, I will. See you soon.
Sure, sure.
Yes.